inventory management. So ladies and gentlemen, first of all, I would want a good student here to really talk to us this afternoon, this early afternoon. When somebody mentions this word inventory, what comes to your mind? What is inventory? What is inventory? Can somebody talk to me this early afternoon? What is inventory? When somebody mentions this word inventory, what comes to your mind? Gay says stocks for sale, stock in and out, stock investment, stock held for purposes of sale. Great. Ladies and gentlemen, you are right. So whenever we talk of inventory, we are basically looking at, it will be quite hard, for instance, for us to predict the exact demand. Where, for example, we'll come and say that if we produce 5 goods, exactly 5 goods will be bought. It's not possible. At times we will produce these 5 goods and demand outstrips. Demand becomes higher than the 5 units you produced, and as such, you'll be able to sell everything. At times, in this case here, you will produce 5 and demand is only 1 unit. Demand is only 1 unit. So in this case here, you'll be left with 4 units, which of course you have to store as your stock items. So when you talk of inventory, we are looking at, ladies and gentlemen, inventory represents the stocks. Stocks of what here? Raw materials. Stocks of raw materials. We have here finished what here? Finished goods, and work in progress, and work in progress. In this particular, ladies and gentlemen, in most cases are measured at the end of an accounting period. End of an accounting what? An accounting period. So stocks of raw materials, finished goods, and work in progress measured at the end of an accounting period. Measured at the end of an accounting period. That camera of mine is not very sharp the way I would wish it to be sharp. I would want this to be sharp. Yes. Great. Measured at the end of the accounting what year? Our accounting period. So we are talking of 3 things. Raw materials, right? We have in this case, ladies and gentlemen, finished goods, work in progress at measured at the end of the accounting period. Ladies and gentlemen, for your level here, can somebody talk about something small regarding to this? The JIT, the JIT, just-in-time system. Just-in-time system. No closing stocks. I like that. No opening stocks, of course. No storage cost. I like that. There are no stores, basically. Just-in-time, ladies and gentlemen, is a system that believes in what we call zero inventory. Zero inventory. It believes in zero inventory. And the model is so famous with Toyota Japan. Toyota Japan, very famous with Toyota Japan. If you go to the history, you'll be able to get information, quite a lot of information on Toyota Japan regarding to how they were able to save on their storage cost almost 100% by adopting just-in-time water systems. So ladies and gentlemen, under just-in-time systems, we'll not be having stocks of raw materials. So we'll ask our suppliers to deliver just when we want to use their materials in our finished goods. So you'll get a situation where even some of these suppliers have been trained in our processes. So wanajua kama ni gari, kama nule anajua yakiona gari imefika ama ile ERP system. They are simply prompted and then they bring their goods when exactly they are needed. So also for the finished goods, if it's just in time, we produce, the moment we finish producing like this, a buyer is on the other side. A buyer is on the other side. A buyer is on the other side to take, because we don't believe in stocks of either raw materials, work in progress, nothing like that. Hiyo fika mwisho wa mwaka atuanze kusema tuko na gari kalijengwa kanusu kanahesabiwa kama stock kat work in progress. No, everything ni perfect. And the major advantage of this, ladies and gentlemen, of just in time is a high reduction in terms of what here our storage cost. So our storage cost in this case here will really reduce to almost zero. But now the major disadvantage will be the concept of what here stock out. So you stand in this case here to disappoint very many of your customers. Not unless you're looking at perfect systems like the Toyota Japan, where you will get in this case here, for example, suppliers just existing for them because they know that that is a senior company. When you're told to supply particular components here, you know that these guys here will be able to sustain us even for a whole year. So I'll be able to set up machines as a supplier simply. My systems here simply to support Toyota Japan. But now here in Kenya, which companies can really give you that kind of a comfort zone? Where you know that I'll be with this company, RCM, for example, just delivering, photocopying papers alone, so that I'll easily know when has RCM in this case here, for example, gotten new students. We take photocopying papers there, they run past papers, they give to students. So here chances are you will really disappoint your final consumers. So there will be very high stock out costs. Very high stock out costs. So I'm repeating again, the disadvantage of this model is the disappointment fee. Of course, there are other disadvantages, but I would want you to just understand the major models. Ladies and gentlemen here, what are we supposed to understand again in terms of these stocks, ladies and gentlemen? We have what we call the simple EOQ model. The simple EOQ model. Never ever should you go looking for deriving the formula. Deriving the formula is not at this level. Deriving the formula, we normally do it in section 2. For us, we are supposed to know that EOQ, economic order quantity, let me not assume so much. EOQ stands for economic order quantity. Economic order quantity. To get economic order quantity, ladies and gentlemen, there is at least a square root somewhere. So could you kindly finish this for me? Somebody finish this for me. Give me the formula of EOQ. EOQ equals. Very good. So square root of 2 DCO all over what here? Holding cost. 2 DCO all over holding cost. Where D is the annual demand. D is the annual demand. CO is cost per order. And then you have got HC, which stands for holding cost. Holding cost. Great. So, ladies and gentlemen, what will happen is this. Look at what will happen in your exam. This is what will happen. You'll get a situation where your examiner gives you this kind of a question. He tells you that a company's monthly usage, the monthly usage equals 200 units. Then he goes ahead and gives you the holding cost per unit per annum. Holding cost per unit per annum is 10 bob. And then he gives you cost per order. He'll give you cost per order, for example, 300 shillings 300. And then number one requirement will be the EOQ, economic order quantity. And then number two, this person will come and ask you to ascertain the total cost of EOQ, the total cost of EOQ, total cost of EOQ. Is there anybody who has already gotten an answer for this? Is there anybody who has gotten an answer for this? It's an illustration. It's an illustration. Given you monthly usage, monthly requirement. So I need to get D out of this. To get D, here, my D will be 200 times 12 because D is annual demand. D is annual demand. So could you kindly give me the final answer here? D 200 times 12 gives me what figure? 200 times 12 gives me what figure? 2400. Thank you very much. Now, once I have this 2400, then to get my EOQ, I'll come and talk of the square root of 2 DCO all over HC. The square root of 2 DCO over HC. 2 DCO over HC. 2 DCO over HC. So in this case here, we have the square root of 2 times annual demand. You're the ones who have given me the annual demand as 2400 times cost per order. This is my CO. Every time we make an order, we incur 300 shillings all over our HC, which happens to be what here? Our HC, which happens to be 10. Our HC, which happens to be 10. So could you kindly give me this answer? So you say 2 times 2400 times 300 divided by 10, divided by 10 equals whatever you get. You say square root. Patricia is confirming 379.74. There is no problem. Please write it in decimal form. No problem. There is no problem. So, ladies and gentlemen, there we are. How about the total cost of this arrangement? Total cost of acquiring this quantity. How about the total cost of acquiring that quantity? How about the total cost of acquiring that quantity? So total cost, ladies and gentlemen, we know for EOQ purposes that total cost should be equal to ordering cost plus holding cost. Ordering cost plus holding cost. Total cost equals ordering cost plus holding cost. Ordering cost plus holding cost. So, and how do we get ordering cost? To get ordering cost, we normally talk over number of orders. Number of orders multiplied by CO. Number of orders, where we take the annual demand divided by the quantity multiplied by CO. Plus our holding cost is always on the basis of our average inventory. Our holding cost is always on the basis of average inventory. 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 So, ladies and gentlemen, remember, whenever we talk over economic order quantity, if you remember, we expect our total ordering cost to be exactly equal to holding costs. At EOQ, this is just for a reminder for your information, for your knowledge, that at EOQ, ordering cost will always be equal to holding cost. Very important. Ordering cost will always be equal to holding cost. Holding cost. So let's see whether this will hold. So what is our annual demand? You had given me a figure of 2400. Divided by Q. Q, of course, in this regard, Q is economic order quantity. And the economic order quantity you gave me was 379.74. 379.74 is the economic order quantity that you guys gave me. Thank you very much. Times cost per every time we place an order. This is cost per order. Every time we place an order, we incur how much? 300. Plus the same Q. The same Q is 379.74 all over average stock. Remember, it's average stock. Times holding cost per unit, which is 10. times holding cost per unit, which is 10. So I would want you guys to do me a favor. I know you've got powerful calculators such that if you wanted to get the total at once, you can do that very easily. But I would want you to do me a favor. Please get this separately. Give me an answer, get the other one separately. Apart from slight difference brought about because of what year, rounding off errors, we expect to get what year, the same. I'm being reminded that this is supposed to be 4-7. 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 I'm being reminded that it's supposed to be 4-7, 4-7. So is there somebody who has the total cost of the first component? The first component. Caro tells me it is 897. 897.38. So I expect also the other one to be quite close to this. I expect the other one to be very close. Apart from rounding off errors, I expect the holding cost to be close to this. Olivia tells me it is 1897.35. You can see the difference is being brought about because of what here? Our EOQ, which has decimals that we never took all of them from our calculator. Of course, you have to truncate our decimals because of rounding off errors, So then what is our total cost here, somebody? What is our total cost here, somebody? Mengich tells me 3794. Oh, yes, it's supposed to be a decimal, that one, yes. 3794.73 or 74. Thank you. Kenya shillings like that. Now, ladies and gentlemen, if you have been able to appreciate this, there is this small question I normally see so many students being asked here and they are not able, or other students being asked, and so many of them do not give us the correct position. Simple things. You'll get in this case here somebody asking you to give us any 3 assumptions of EOQ. Assumptions of EOQ. Is there anybody who can remember? Just 3. There are like 7, like actually 10, but I only need 3 from you. 3. Yeah, that very good, ladies and gentlemen. That we have our EOQ formula, which is the square root of 2 DCO over HC. That our costs, all costs, that is CO, HC, and the purchase cost. Remain what here? They remain constant. All costs in this case here, the CO, HC, and the purchase cost remain constant. For the model to work, they have to remain what here? For the model to work, they must remain constant. For the model to work, they must remain constant. Yes. Ladies and gentlemen, again, out of this, I'll be able to see straight away that annual demand is known in advance, and will remain constant. And then we have number 3, ladies and gentlemen. Number 3, that lead time is always constant. Remember, lead time is the time between placement of an order and the actual receipt of goods. The time between placement of an order and the actual receipt of goods. That is what we call what here, somebody? That is what we call lead time. When do you place your order? On Thursday. When did I get my order? On Saturday. So that time lapse between placement of an order and the actual receipt of goods is what we call lead time. We're saying that for this model to work, ladies and gentlemen, that lead time must be known in advance and will remain what here? Will remain constant. That is very important for me. Ladies and gentlemen, also remember that replenishment, is in equal batches, and instantaneous, and instantaneous, and instantaneous. You'll have to get the spelling of this. As we grow older, spellings disappear. Instantaneous. I think this is supposed to be E. Instantaneous. We'll be able to get that. Instantaneous. Meaning that this quantity that we are going to, for example, we have our annual demand being like 2,400 units a whole year. So we expect once we get our EOQ, for example, of 200. So that is what we will be calling the replenishment, what you're giving us, what you're supplying us. That supply has to be instantaneous. When we ask for 200 units, usilete units tano tuambie mazee kwanza tumianga hii. Hiyo kitu hii apply. When we talk of, ladies and gentlemen, this replenishment here, it has to be in equal batches, batch of 200, 200, 200. And then number two, the units here must be delivered, the ones we order, must be delivered, all of them at once. All of them at once. All of them at once. There is the assumption of there being no stock out. No stock outs. Stock outs in this case here are never tolerated here. They are never tolerated here. From, ladies and gentlemen, we have what we call the economic batch. The economic batch. The economic batch quantity. The economic batch quantity, EBQ. We have what we call the EBQ, economic batch quantity, EBQ. How could I write that up until my students can't even see? It's economic batch. It's economic batch quantity. It's economic batch quantity, EBQ, like that. So now, ladies and gentlemen, for EBQ, what are we supposed to know? That this one is normally used for those organizations that produce goods for internal consumption, used by firms that produce goods for internal consumption. Goods for internal what here? Consumption. They produce their own goods for internal consumption. For example, a good example will be like Toyota. Toyota, for example, in Kenya, which is a car manufacturing company. Of course, they don't manufacture anything here, they bring, but assuming they were manufacturing. And then now internally here, Toyota company, for example, producing their bolts and nuts for their internal what here? Consumption. So if that is the case, then ladies and gentlemen, this is a perfect example of a company which should go ahead and use what here? EBQ model, economic batch quantity. Economic batch, the question will be, what quantity should they produce? What quantity should they produce, right? Which will be economical for the entire organization. For the entire organization. So could you kindly do me a favor, ladies and gentlemen? Could you kindly go ahead and give me the formula of EBQ? Is there anybody who is able to give us that formula of EBQ? EBQ will be equal to what? EBQ will be equal to, let's see, let's compare notes. EBQ itakuwa sawa na nini? EBQ itakuwa sawa na nini? 2 times, very good. 2 times cost of setup times demand. Nimesahau denominator. Lakini kitu mimi amenifurahisha zaidi, kama si vile mwezi kwa kona tungempatia chai. Mwezi tu ndiko pabaya. Tungempatia chai. At least amejua for ladies and gentlemen, for economic batch quantity model, we don't use cost of ordering. We are not ordering those goods from outside. What we shall do is to set up machines internally and produce our bolts for internal usage. So in this case here, we shall be using what we call cost of what year setup. So most importantly, ladies and gentlemen, when we talk of EBQ, this will be equal to the square root of 2DCS all over HC. But remember that this HC has to be multiplied by some reduction factor. Reduction factor because, ladies and gentlemen, as we produce these bolts, of course, on the other side, we are utilizing them. Utilizing them. So in this case here, the reduction factor will be 1 minus U over P. U over P. So instead of saying 2 DCO, now we are talking of CS. So CS, ladies and gentlemen, here stands for cost of setting up machines. Cost of setting up machines. Cost of setting up machines. Of course, the HC will be holding cost. HC will be holding cost. U will be usage. Usage. And in this case here, P will be the production rate. The production rate. The production rate. This usage rate, production rate. Production rate. Can I wrap this? Yes, thank you. So, ladies and gentlemen, here we have an illustration. So illustration, of course, CS will be given to you. They'll tell you CS cost of setting up the machine is, for example, 1,000. Then they'll go ahead and give you like 200 per month. Production rate must always be higher, like 300 per month, right? They'll come and give you HC, like for example, 10 shillings per unit per annum. Per unit per annum. And then will be required, ladies and gentlemen, here, number 1, to determine, you determine EBQ. You determine EBQ. And then number 2, you determine the total cost. You determine the total cost. Total cost. So can I give you a minute to try the question, or I just do it? We try. Thank you very much, Mwende. Thank you very much, Mwende and Naomi. Beth is asking FR. I'm not so sure what FR stands for. D stands for what here? D stands for annual demand, which is the same as annual requirements, which is the same as annual usage. So the annual usage, we have monthly usage is 200 times 12, which of course will end up giving us 2,400, which will end up giving us 2,400. I like how Patricia is putting it. Kwamba demand and usage. Usage. Thank you. Thank you. Now, ladies and gentlemen, once I have this, then I'll be able to give you the U over P. U over P. I don't have to change these to yearly. Even if I change them to yearly, because at the end of the day, I'll be dividing them. You see, at the end of the day, I'll be dividing this. So the 12 and 12 will do what? So I don't have to change those to yearly. So usage will be 200 over 300, which will give me 2 over what year? 2 over 3. 2 over 3. 2 over 3. So, ladies and gentlemen, how about 1 minus usage over P? It will be 1 minus 2 over 3, which will be 0. What here? This will be a third. So a third will be 0.333, like that. Great. And then therefore, my EOQ will be equal to the square root of 2 DCO over HC, which will be square root of 2 times the annual demand. Annual demand is 2,400. 2,400 times cost per order. Cost per order, cost per order. You don't have cost per order. This is supposed to be CS. Sorry, I'm getting EOQ. No, should be EBQ. EBQ. Ingekuwa kwa mtihani mimi ningenyoroshwa, lakini ningekumbuka haraka sana. Should be 2 DCS, and if it's CS, then this will be 1 minus U over P. So then 2 times 2,400 times our CS. Our CS, which happens to be 1,000. 1,000 all over HC. HC over how much here? Somebody of 10 times the reduction. Times the reduction, like that. Times the reduction. So then that will be 2 times 2400 times 1000 divided by open brackets here for the denominator, 10 times 0.333 minute threes. Put brackets there, and then you say equals. So when you say equals, you'll end up getting what, somebody here? 1200. If you get 1201, if you get 1199, I'll still give you a mark. I'll still give you a mark. But optimally, save for rounding off errors, it should be exactly what here? 1200. So I don't know whether we are together up to there. Are we together up to there? Are we together up to there? Thank you very much. Thank you very much. Great. Great. And then now you're supposed also to understand the concept of discounts. So we have here discounts. So for example, somebody will give you the price per unit is 10. And then the holding cost, the holding cost, they'll give you 10% of the price, for example, right? Cost per order, they'll give you 1,000. Cost per order. Beth is asking a question there, total cost. Yeah, then let's go back a little bit. Let's go back. Let me first of all forget about this. We go back a little bit. So total cost will be equal to, we have here total setup cost plus what here? Plus holding cost. Total setup cost plus holding cost. So then this will be D over Q CS plus Q over 2. Whenever I see this HC must always be reduced by that factor. HC must always be reduced by that factor. HC must always be reduced by that factor. So we move slowly. So the D here, annual demand, ladies and gentlemen, what do we have for our annual demand? Annual demand is 2,400, right? Over Q, 1,200. Cost of setting up the machines. Cost of setting up the machines, I've forgotten this figure. Cost of setting up the machines, I've forgotten the figure. Was it 1,000? CS, cost of setting. 1,000. Thank you very much. 1,000 plus the Q, which is now the EBQ, economic batch quantity of 1,200 over 2 times HC. I suppose HC was 10. I suppose HC was 10. I suppose HC. Was it 10? HC. Yes. So times, remember the reduction factor, you are the people who gave me the reduction factor of 0.333 after you took 1 minus U over P. You're the ones who gave me that reduction factor. Remember this reduction factor of 0.333? The reduction factor, this one here. So then could you kindly just give me the final answer? Kindly give me the final answer. I think there is one student who got it right. Kindly give me the final answer. Kindly give me the final answer. Can somebody give me the final answer? 4,000. Thank you very much. 4,000. And if you want to know that you're right, always this cost here must be exactly equal to this cost. If you forget this reduction factor, the two will never be the same. The two will never be the same. So you're supposed to get 4,000. Even that 980 that Esther Lokai has gotten still will give you all the marks there. Will give you all the marks there. So sorry for that. So then let's go to the discount. Let's go to the discounts. Let's go to the discounts. Let's go to the discounts. So for the discounts, ladies and gentlemen, what do we have there for the discounts? So we have CO over 1,000. Right? Right. Then they have given us the annual demand. Annual demand, they have given us 20,000 units. Annual demand is 20,000 units. So we are required here, number one, to determine EOQ. Determine EOQ. Determine EOQ. Determine EOQ. Determine EOQ. Determine EOQ. That one by now, somebody should have given me an answer, because EOQ is about remembering the formula, square root of 2 DCO. The students who used to tell me that, Mwalimu, if you want us to remember this formula very easily, EOQ, talk of square root of twice chord. I don't know why they like chord. I don't know. Chord. To them, chord makes them remember this formula very easily. So then the very first thing that I will do here is to come and get the proper HC. Yes, we need to come and get the proper HC, which has to be in terms of money. So HC here, ladies and gentlemen, will be 10% of the price. And what is the price here? The price is 10 bob. So this gives me 1. This gives me 1. This gives me 1 bob. This gives me 1 bob. Now, ladies and gentlemen, listen here. After I get this HC, then I'll be able to get for you the EOQ, which will be the square root of 2 DCO over HC, which will be equal to the square root of twice annual demand. Annual demand, ladies and gentlemen, already I have a figure of 20,000. Cost per order is not lost on me. I know cost per order is 1,000. All of HC that right now I've been able to know is 1. So please, first of all, start with what is under the square root. So we have 2 times 20,000 times 1,000 divided by 1. Whatever now we get, we say square root. Whatever we get, we say square root, which will end up giving us 63. 63, 24, 24 units. 24 units. Let's go to number 2 of this question. Mention number 2. Mention number 2. Mention number 2. Mention number 2, that the company has a quantity discount offer of 15% if it acquires at least 7,000 units. 7,000 units if it acquires at least 7,000 units. So we are required under this, required to determine the optimal decision. Optimal decision, i.e., should we accept the quantity discount offer or not? Should we accept the quantity discount offer or not? Great question. Great question. Solution. Now, because here they have mentioned the issue of what? Quantity discount. This is how I will write my formula. Now here it will be very important for me to state that, because of quantity discount, because of discounts, purchase cost becomes relevant. Cause of discounts, purchase cost now becomes what? Relevant. Purchase cost becomes relevant because now you shall be evaluating 2 alternatives, right? because discount affects what? Purchase cost. Discount affects purchase cost. So purchase cost now becomes what here? Relevant. Purchase cost now becomes relevant. Now, ladies and gentlemen, what we will do here is to come and write the formula of total cost. So my total cost here will be equal to purchase cost plus ordering cost plus holding cost plus holding cost. So total cost equals purchase cost plus ordering cost plus holding cost plus holding cost plus holding cost. So purchase cost, how do we get purchase cost? I always remember Mwai Kibaki's party. DP. Ile chama ya ta. DP plus ordering cost. Ordering cost is D over QCO plus Q over 2HC like that. Q over 2HC like that. Please write there that D is the annual demand. D is the annual demand. D is the annual demand. P is price per unit. P is price per unit. Price per unit. Now, so step number one. Step one. Evaluate the cost of the discount quantity. Evaluate the cost of the discount quantity. Evaluate the cost of the discount quantity. So, ladies and gentlemen, if we want to get the discount, then we must procure how many units? Here, somebody, we must procure 7,000 units at least. Remember, for inventory purposes, when you're told that you can buy 7,000 or more, you don't go for more. Where will you store those things? Because somebody can give you like even 80% discount, but it tells you acquire 1 million units. So storage will be a problem. How will you be able to sell? There are very many factors. So when somebody talks of at least 7,000 units, always acquire the smallest quantity, which will give you a break, which will give you a price break, which will give you a discount. So in this particular case, we shall acquire, i.e., the cost of acquiring, 7,000 units. The cost of acquiring 7,000 units. So if they talk of 7,000 or more, I'm not interested in the more. I'll simply ask myself, what is that smallest quantity that I need to procure for me to get that price break? It is a price break that I'm after, that I'm interested in. So that I would want to give them the cost of acquiring these 7,000 units, and I would want you guys to get me started. If I go to this particular company asking them to give me 7,000 units at once, then what will be the price per unit? Please give me the price per unit. The price per unit will be equal to the original price. What was the original price per unit? What was the original price per unit? 10. So it will be 10 times 85%. It will be 10 times 85%. Where have I gotten the 85% from? It is because of what here, the discount that you're getting, 15% being knocked off. 15% from 100% is 85%. So then that will give us what figure, somebody, as our new price, the discounted price, the great price. That will give us how much here, somebody, 8.5. Ladies and gentlemen, this is something that so many students have always confused. When the price goes down, we expect the holding cost also to go down, because holding cost has been given as a 10% of what year of price. So please don't work with one in this formula here. Holding cost has been given as a percentage of the price. To be precise, it is 10% of the price. So it is 10% of 8.5. So 10% of 8.5 will give us what, ladies and gentlemen, here? 10% of 8.5 will give us what, ladies and gentlemen, here? That I'm being told gives us 0.85. And then now everything now will be about plugging in this into the total cost equation. So come and give us the total cost. Please, we are following this formula now. So we start with DP. We start with the demand. Who is able to give us the annual demand? Who is able to give us the annual demand? Annual demand will be equal to what? Somebody talk to me. Annual demand will be equal to what? Yes, somebody talk to me. 20,000 times, of course, the price per unit. I'm quite cognizant of that. It is 8.5. It is 8.5 plus, ladies and gentlemen, we have here D over Q, D over Q, D over Q. It is 20,000. How many units are we acquiring this time round? At once. How many units are we acquiring this time round at once? Thank you very much. It is 7,000. This is the quantity. The Q there is 7,000 times CO. Is there anybody who is able to remember the CO? Is there anybody who is able to remember the CO? The CO, cost per order. 1,000, Naomi tells me that. CO is 1,000, is 1,000, is 1,000, plus Q over 2. So the Q here, the Q, what quantity are we acquiring for us to be able to get that icebreaker in form of a discount? It is this 7,000 over 2 times our holding cost. Our holding cost is given here, which is 0.85. Holding cost is given there, which is 0.85. So times 0.85 times 0.85. So could you kindly give us the final answer now? Kindly give us the final answer. Kindly give us the final answer. What figures are they able to get there? Total cost. They don't want to give me an answer. 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 So Caro tells me, they're giving me different answers. Dennis has his, Caro has hers. So I don't know who is telling us the truth. That 17 has been repeated there twice. 1758.32. 1758.32. 1758. 1758.32. Thank you very much. So Dennis, please check out. You may have missed out one figure. You may have missed out one figure. You may have missed out one figure. Thank you very much. Now, ladies and gentlemen, that is the first step. Step number two. Step number two. Step number two. Step number two. You determine the total cost of EOQ, total cost of EOQ, i.e. ignore the discounts. Ignore the discount. So we say, what if we don't want that discount and we decide to work with the economic order quantity? What is going to happen? If I decide to work with the economic order quantity, what is going to happen? What is going to happen? So if I ignore the discount, then it means that I'll procure the EOQ, whose amount I have forgotten, whose value I have forgotten. EOQ we had obtained 60 something. EOQ had obtained EOQ 6324. 6324. Thank you. 6324. So then I would want you to give me the total cost of these. So how do we get total cost? So the total cost will be DP plus D over QCO plus Q over 2HC. Don't tell me, Molim, but that is EOQ. It is EOQ inside a question that has got a discount. So long as the question has got a discount, all the quantity to be purchased options must be evaluated using this full formula. Let's now move slowly. Let's move slowly. Let's move slowly. Can somebody help me to get out the cost here? What is the annual demand? 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 20,000. How about the price, buying price per unit? 10. Demand still remains 20,000. Do we know what quantity we are going to procure this time around? Do we know what quantity we are going to procure this time around? Do we know it? Do we know it? Do we know what quantity? 20,000? No, it is EOQ. It's EOQ 6324. Thank you. How about cost for each order? Cost for each order. How about cost for each order? Cost for each order, I'm being told, is 1,000. 1,000 plus Q over 2, the same Q. The economic order quantity. The economic order quantity is 6324 all over 2 multiplied by HC. They must have forgotten what HC was. If you're not taking into consideration, ladies and gentlemen, of any quantity discounts, then automatically our HC will remain at 1. HC will remain at 1. HC will remain at 1. So automatically, HC will remain at 1. HC will remain at 1. Great. Thank you. So what are we getting there? Final answer. 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 Inakuja ngapi woye? The final answer inakuja ngapi? Inakuja ngapi? Timu ameshanipatia. Timu amenipa wamenipa 2063. 24. Thank you very much. Kenya shillings. Now, between the two options, which option is cheaper? Is it the one that has got a quantity discount or the one that doesn't have a quantity discount? So compare the two costs, and then you tell me, Mwalimu, if you want to minimize your cost, please go for discounts or ignore the discount. With the discount. So in this case here, in conclusion, the firm should accept quantity discount. The firm should accept quantity what here? Discount. The firm should accept quantity discount. The firm should accept quantity discount. Quantity discount. The firm should accept quantity discount. So, ladies and gentlemen, that is it.